Alright, good night to everyone. So, let me pull up our topics. You guys hear me?
Yes, sir.
Yes, sir.
Alright, great. So, we're finished with computer fundamentals, we're finished with networking, the implications. Well, we didn't get to cover Word, spreadsheet, and database. So, we have a few more chapters of programming to try to finish off. We'll try to cover that tonight quickly as possible. And if we get some more time, we see what else we can push in as quickly as possible also. So yeah, so remember, if you miss anything, I guess it's this playlist here, CSEC Information Technology. So this one has everything, all the topics that we would have covered in case you missed anything. Alright, so quickly, programming languages. So remember, we're going fast. If you need me to repeat anything, if you need me to clarify anything, you have any questions, concerns, comments, suggestions, anything, stop me, let me know, or type it in the chat, whatever you're comfortable with. Alright, let's go. So, Chapter 9. Chapter 9 introduces the concept of problem solving by writing algorithms and drawing flowcharts. So that's how you solve problems in creating a program. You first design an algorithm or you design a flowchart. It is during the implementation phase that an algorithm is going to be converted into actual programming language statements called source code. So the code that you're going to use in the programming language. So when you guys were creating your SVA and you were typing a series of code for your SVA, for example, you would have typed var, and this is initializing, and then you typed begin, and that you have the body of the program. All of this is called the source code. So the code that you use to create the program, that is called your source code. Now in this chapter, we share some examples of programming languages to introduce the process of writing short programs. So the implementation phase. In this phase, there are four main steps. You translate your algorithm into the programming language. So why are we using the word translate? Because remember, the algorithm should be so simple. It's like if you are converting one language to another. You simply read one line in the algorithm and you convert it into the programming language. Examples of programming language: we have BASIC, Pascal, C, C++, Visual Basics. For applications, which is called VBA. So please do not confuse BASIC with Visual Basic. Now, if you have a correct and precise algorithm, the translation should be almost line by line. Now, the second step, locate and correct any errors in the code. So basically, when you are translating and you type in the information, you're going to get errors. So you're going to get a syntax error. Now, syntax errors are errors resulting from incorrect use of programming language syntax or violation of syntax rules. What are the syntax rules? Well, the syntax rule is basically like English. In English, you have certain rules that you're going to follow. For example, subject and verb agreement. What should come first, the subject or the verb? The verb or the subject, whichever one. Now, similarly, in your programming language, you have certain rules. For example, when you're using the syntax right, the rule is basically to put the information in a bracket. So when the source code, when the program does not follow the correct syntax, when you, the user, puts in the wrong syntax, you don't follow the rule, that is what we call a syntax error. You basically use the code wrong. Now you have a logic error, next type of error. So these two types of errors, you should remember what they are. So we have a logic error and we have a syntax error. Now the logic error is made by the programmer, such as those made by wrong signs, arithmetic operators, and so on. So Basically, the syntax, you didn't follow the rule that is specified by the system. They say to put something first, then put something second, but you basically mixed it up. Now, for the logic error, you made a mistake. You're the one that put in the wrong calculation, you put in the wrong information, whatever the case may be. So, those are your two types of errors you will encounter. Now, your third step, you're going to execute the program code. So, this is going to include testing the data. So, this is where having a sample data, you test that to ensure that the program is working and it can produce error messages. Why do we need the program to produce error message? Well, if you can remember the algorithm phase, one of the feature of the algorithm or the program is that it must accept all types of inputs. So say for instance you're creating a calculator. That is your program to calculate numbers. Now obviously you cannot calculate letters, but you still allow the program to accept letters. So when you do accept that letter now, you are going to produce an error message. Tell the person basically, error, letters not accepted. Please enter a number. So that is what is being indicated here. Now fourth, maintain the program. What is maintenance of the program? This includes documenting the program throughout the coding process by writing comments on how to use the program, as well as comments within the program. So whenever a person is using your program, they will be able to know how to use it basically. Remember, if you have any questions, comments, make them known. Now, choosing the programming language. Programming is the art of writing the solution to a problem using a language that a computer can interpret. A programmer usually instructs the computer how to solve a problem since it cannot come up with a solution to a problem itself. So basically, a programmer tells the computer how to work. How does it tell the computer how to work? By creating a program. A program has the instructions inside of it. The software has instructions inside of it. Hence, a computer program is a set of instructions that tell the computer what to do and how to do it. These instructions, they're usually converted into a sequence of numeric code called machine code, which is stored in memory. So these codes that you're typing here in your program, for example in Pascal, this is what you would have typed in your Pascal program. Even though they're normal alphabet, numeric type of characters, this is not what your computer sees. Your computer cannot understand this because that is called high-level language. Only you can understand that. So that is why your computer, whenever you run a program, that program or software needs to be converted into numeric code called machine language. That code, that programming language needs to be converted into zeros and ones, which is basically binary, also called machine code. Now the central processing unit is what is going to interpret this code in order to carry out the instructions. So basically also your CPU only reads machine code, binary. So first, you select the type of programming language that is suitable for you, whether that's Pascal, whether that is C, whether that is Python. You select your programming language. There are many programming languages that can be used to write a program or create other kinds of software. These languages are grouped into two categories. The low-level language, which is machine code, and then your high-level language is what you can understand. So that is your basic, Pascal, C, C++, Visual Basics for application. Those are your high-level language. Now low-level languages, these languages are machine dependent. That is, the code written can only be understood by the computer or processor that is used to write the code. So only the machine can understand it. Hence, it's called a machine code. Machine codes use digits 0 and 1 to make up binary code. So the combination of 0 and 1 gives us the machine code. Now the advantage of this here is that the code runs very fast, efficiently, because it can be directly executed by the CPU. So it's basically the CPU sees what it is understanding. It's like how you just understand English. I'm speaking English to you, so you are processing it right away. You don't have to translate it. Same way, the CPU only understands zeros and ones. So once we send 0 and 1s to the CPU, it's much faster, it's much efficient, it understands it right away, other than having to translate it itself. So like if somebody was speaking French to you, you have to go and translate it. Now the disadvantage. The programmer may become confused with the massive amount of zeros and ones. So we don't understand what 0 and 1, for example. You don't know what this is here, so it's going to confuse you. Hence why we don't program in machine code. Now assembly language. Assembly language has the same structure and commands as a machine language or machine code, but allows programmers to use abbreviated words called mnemonics instead of binary. Now assembly language is actually in the middle of low and high level. So between these two here is where you're going to find assembly language. So the low level language uses the binary, the zeros and the 1. Now what they try to do, as I just read here, is that they try to abbreviate the 0 and 1s and give them certain abbreviations. Let me see if I find an example quickly. So we can simply use this as an example. REM. Now instead of REM, DIM, we're just using this as an example. So instead of you seeing 000100, we represent that with REM. But at the same time, you don't know what REM means. You don't know what DIM means, and so on. So even though they represented the binary with an abbreviated word, it was still a bit confusing to persons. So it wasn't as clear as the high level language. So but it still had words. It still had words that you could try to figure out or you could learn eventually. So the assembly language, as mentioned already, is between the high level and the low level. So instead of writing the binary, the equivalent assembly language could be add A and B. So this here would have represented the keyword here, add, would have represented the binary of adding, generally meaning adding the contents of A and B. Now what's the advantage of this? It can be easily converted to machine code because it was much more closer to the machine code. And you use what is called an assembler. An assembler is what you use to convert assembly language into machine code. It converts assembly language into machine code. We use an assembler. Now the disadvantage is that it was difficult to understand compared to high level language. So high level is what we completely understand, but the assembly, it still had some forms of learning even though it had words. Now the high level language, remember, once again, you have any questions, concerns, let me know. High level language, they're different from low level language in that they're not machine dependent. Therefore, programs written on one computer can generally be used on another computer. So whenever you write the program in high level language, it's a structure that any computer can basically understand. So you can put it on your laptop, you can put it on your desktop, and you will be able to understand it. Now they also use keywords similar to English, and that's what made it easier to write and use. Now these languages are designed to be easier for you to understand. They are converted to machine code. So remember, the high level has to be converted to machine code because your machine could only read this here, rather than translating from one language to another. So that the computer can carry out the instructions in the CPU. Now, what's the advantage of this? It has English words, so it's easier for you to create the program. The advantage of high-level language, it has English words, so it's easy for you to create the program. But the disadvantage is that you have to convert. So it takes time for it to convert, and that's what might take up the time in a program basically running. So Pascal was named after the 17th century mathematician Blaise Pascal, a language that uses structured programming, mostly used for teaching purposes. Pascal is easy to learn and an alternative to BASIC. VBA is a programming language developed by Microsoft and derived from BASIC. So from BASIC we got VBA. Programming in VBA uses graphical user interface using drag and drop technique from a form window. Controls such as text boxes and buttons are used to design the layout on the form to work with Microsoft applications such as Word, Excel, Access, and so on. Alright, so moving on to the next chapter, if you don't have any questions. Alright, so next chapter, writing a program. So all the different programming language have slightly different code and data type. For the most part, writing the code becomes easier to practice. So the 2020 syllabus does not specify a recommended programming language. So you basically, they won't be testing you on VBA language, Pascal language, and so on. But you still have to know, like, understand what's the structure, what's the layout of making use of them. So once the programming language has been selected, you start writing the program. Once you have designed your algorithm, test it on paper. So you design the algorithm, test it on paper, which is called your trace table. Remember, testing the algorithm is called a trace table. You need to use a text editor to type the program. So text editor, a normal text editor such as Notepad, Notepad++, even Microsoft Word, those can all be used to type a program. Just a simple text editor is needed. Now, most programs provide an editor that can be used to type your programming language. So there are some programs that have a specialized software that you can use also. Now, most programming language have different syntax and semantics which you may follow. So basically, like how different languages have different rules that you would follow to construct sentences, different programming language have different rules called syntax and semantics. Now, what is a syntax? Syntax is a very precise way in which the statements in the program must be written in order to be understood. So that's like how I mentioned, when you're using in Pascal, you have to do write and then an open bracket and then a quotation mark, and then you put your information inside. That is called the syntax, the rule that you're going to follow. Now, it is a set of rules for combining the various elements that make up the programming language. The syntax allows the programmer to create a correctly structured statement that is legal, although it does not guarantee the statement will be useful. So even though you follow it correctly, doesn't mean it will actually help you. Semantics. What is semantics? Semantics is the meaning associated with the word. What is the meaning associated with the word? Symbol or punctuation that makes up the language. For example, if you see a semicolon in Pascal, it represents the end of a statement, while in other languages it might have another meaning. Statements are constructed from various programming elements, so the overall meaning of the statement is determined by the language semantics. So semantic is the meaning of the words, the symbols, the punctuation that you are going to be using inside of the programming language. The syntax, that is the rule that you're going to follow to create the programming language. Now, program structure. Nearly all programs have a similar overall structure. Did I miss something at the bottom there? No. So, statements to establish the start of a program. Each program must have a statement that's indicating the start of the program. Could include the program headers or comments to state the name of the author, date, and so on. So key point here, each program must have something indicating the start. Then next, you're declaring the variables and the type. So declaration, this is kind of like when we were creating our pseudocode, our algorithm. It's the same pattern here. You had something indicating the start, which is basically a title, and then you declare your variables. Then after that, you could have initialize. And so here, so declare, initialize if you so need, and then after the initializing, you enter basically the body of your program. So now you have your program statements. This is going to be a block of code which is going to include all of your calculations, all your operations, whether it's arithmetic, whether it's relational, whether it's Boolean, whether it's logical, whatever calculation, that's going to be in the body of your program. If you have any conditional statements, if you have any loops, that's going to be in the body also. And formatting output is usually user friendly. So after you finish your calculation, you must get some form of output to show what is the result of the calculation. So all programs have that similar layout, have that similar structure. Now the following is a simple example of a program. We're not going to read through all of that. Rem, output sentence, print hello, and so on. We're not going to go through all of that also. Let's see. Programming sentence, keyword program followed by name of program, then a semicolon. To output, comment, and the purpose. Oh, so when we use curly brackets, that can include a comment in a program. So remember we were talking about semantics. The purpose of the curly brackets is to indicate a comment that you're creating. When you're using a semicolon, that indicates the end of a statement. And even a period is going to indicate the end of your program. What else? Well, we don't need to go so much into the various programming language, but I'm just going to go through this one here quickly, just in case something does come for it. So at the very first, at the very top, we have a title, and the title here is indicating the start of our program. Then next, we have our declaration. So the declaration, this is the name of the variable, this is the type of the variable. Now notice in Pascal, we use a colon to indicate that type, but in BASIC we say age as integer. So that's why they won't really test you on it, because it's too much programming language to actually test you on these specific things. Now here we have declaration. Notice the semicolons indicating the end. Then we have a begin, which is indicating the body of our program. And if you notice, inside of the body we have our initializing. So this is the initializing stage here. We initialize age with 18, cost with 250, and so on. Then we have the output, input, and any calculation, and so on here. So we have a write. Write is indicating we are putting something on the screen. If we see a ln, that indicates we're having a new line in the Pascal program. In this example here, let me go for the, it is the Pascal, yeah, this is the Pascal one. So we have a begin here, indicating the beginning of the body. We have an initializing here once again, and then we have a if. So if form is equal to 3, remember then is for true. So if this statement here, if this process, this calculation here is true, is 3 equal to 3? Yes, that is true. So that means we write on the screen promote it to form 3. But if it was false, we would carry out this else statement here. So it's kind of similar, and if you notice at the end here, we have the ending of our program. So it's kind of similar to our pseudocode, if you can remember that. We have here a loop. So the declaring of the variable here. So this is declaring the variable. Here we have initializing the variable, and here we have a loop. We have a while loop here. We're testing to see if line is less than 10. Now line started off with 0, so line is 0. Is it less than 10? So while do, we begin, and then we go through the loop, and basically this is an update here. So they might ask you a question like this here. What maybe is the purpose of this here? Line plus 1. That's basically updating a variable. And we usually update a variable because we want to monitor the loop. We want to ensure we know how many times we're actually going through this loop here. We have another loop here, so we begin for. Now remember the for loop, it does not need to be incremented. If you can remember why, because we have two types of loop. We have an indefinite loop and we have a definite loop. The definite loop meaning we know how many times the loop should run for. The for loop is a definite loop. We know we want the program to run for 10 times. Hence, we give it a starting value of 1 and we say the ending value is 10. So it's going to run from 1 all the way to 10. And the indefinite loop is when we basically do not know how many times it should run for. So that's going to be our while loop and our repeat loop. So when we do not know how many times it's going to run for, we make use of those there. Now our next chapter, running a program. Now usually you will go through several steps before you can type your program instructions, let alone view the output of your program. So at this stage you're ready to see your program run. After you have typed your program using an editor called the source code. Remember that keyword there, source code, that refers to the program that you would have typed in the text editor. Next, it needs to be tested for correctness. To do so, the source code must be translated into the machine language called the object code. Another term here. Object code is referring to when the source code is converted into machine code. We call that the object code, so that the CPU can carry out the instructions. So once again, the source code is what you're going to type inside of a text editor. That's the programming language you're going to type inside of a text editor. Now when you convert, when you translate that source code into the machine language for the CPU to process it, it becomes what is called the object code. Remember, if you have any questions or so on, let me know. So from source code to object code, converting a program from source code to object code is performed by a translator program. Sometimes a program listing is shown, which is a printout or soft copy of the program source program instruction as a reference while working and coding with a program. Yeah, this is what I'm looking for here. These programs that translate a specific program from one language to another, from high-level language to low-level language, we have interpreter, compiler, and assembler. Now, let me look for... Give me a second. Programming language conversion. Let me see if I can get a summarized image for you guys. Great, this is gonna work. Good. So, as you can see here, we have high-level language, assembly language, machine code, and then the processor. So you're going to write in your high-level language, and then it's actually going to be converted to assembly language, then converted to machine code, but it could go directly from high to machine, but then it's going to go to the processor. Now what converts from high to assembly, we call that a compiler. So if you can actually remember in do I still have Easy Pascal installed? Give me a second. Hopefully it installs quickly. Yes. Easy Pascal. Come on. Come on, you can do it. It's just a simple program. Yes. So if you notice, when you guys were doing your program, you would always notice there's a option called compile your program, because at the top here you would have typed your source code. Why is it not allowing me to type anything? Or is it at the bottom here? Yeah, at the bottom here you would have typed your source code. So when you compile now, this is what would have converted it to your object code at the top here, or well, it would have given you your output, so you wouldn't have seen the object code actually. But the compile there is basically referring to your compiler converting from the high level language to the machine code. Now what converts your assembly to machine code? Once again, your assembler. And you don't have to worry about instruction. Well, instruction execution basically means that machine code is basically going to be processed by your processor. So once again, when you're converting high level to machine, you use a compiler. If you're converting assembly to machine, you use an assembler. And then instruction execution, that basically means that the processor is going to execute the machine code, is going to carry out that instruction. If you have any questions or comments, let me know. Now an interpreter that translates the source program line by line. So if you notice, we have an interpreter and a compiler. Both of them function the same. They operate the same in that they are used for converting high to machine. So where you see compiler here, you can actually add what was it? Interpreter? Yeah, interpreter. Where you see compiler there, you can actually add interpreter, because both of them convert high to machine, high to low. But what's the difference? The compiler is going to compile all of the code at once. The compiler is going to convert all of the code at once, whereas the interpreter is going to do it line by line. So it's going to convert, translate one line, test it to see if it has any error, and then moves on to the next line. Whereas the compiler just converts everything and then tests the code. The interpreter converts one line and then tests the code. If it's okay, convert the next line, test the code. If it's okay once again, convert that line and test the code. So they're both converting high to low, but one converts all of it, which is the compiler, and interpreter converts one line at a time. Now if no errors are detected by the interpreter, the instructions, if they are not detected, the interpreter instructs the control unit to execute the translated instruction. This cycle will be repeated for every instruction in the program. This is an easy but inefficient way of executing or running programs, not written in machine code. BASIC is a language which is interpreted. So BASIC uses an interpreter to convert the source code. So you can actually see it in this diagram here. You have the source code, it gets interpreted. If it's okay, you see the result. But if it's not okay, you get an error, you have to go and fix the source code, and you basically repeat like that over and over. So one line after each other. Now a compiler translates all the program instructions at one time and produces a standalone object program that can be executed and run on its own. So that, as I mentioned already. Now error checks for syntax and logic errors are performed, and an error summary is issued. Now once the program, so A, where's A? I guess it's not a reference. So after you finish converting, it checks for basically all errors, and it's going to give you a summary of all errors. Now once the program is compiled, you have no errors detected. Then the compiler will then instruct the control unit to start executing the program. So remember, when it converts from machine high level to machine, it checks the errors after the conversion. If there is no errors, it will begin to run the program. Now if the program produces incorrect output or stops unexpectedly, then another type of error may be caused. Otherwise, the object program will be executed each time it is run, but the source code only needs to be compiled once. So once you compile the program one time, or basically convert it from high to low, you can run it as many times as you need, once you don't change the source code. This is important to note. You have one set of source code. Let me find an empty area. You have one set of source code here, and say I have a 1 inside of it. Now if I compile it, I could run this this object code, this source code, how many times I want. I could run it how many times I want. But when I go and update the source code, if I continue to run it, it's going to keep the old source code, because I did not convert the new high-level language, the new program, into the new source object code. So what I need to do again, I need to go and compile again. So every time you make a change in the source code, you have to go and compile again. After you would have compiled, then you can run for how many times you want, once you do not make a change to that source code. Now if there are any modifications to the source code, then it must be recompiled, as I said there. Now COBOL is a language which is compiled. So as remember we talked about compiler and interpreter, so you have an example of an interpreter type of programming language, which is BASIC, and an example of a compiled programming language is COBOL. Any questions, any comments? Once again, let me know. Alright, so this diagram here, it shows us the structure of how a program is basically carried out. So one, you create your source code. You basically type out your program. When you're finished typing your program, two, you compile that program. You basically convert it. So you type the program, you convert it. Now if the program, while converting, has some errors, which is going to lead you to a list of syntax and logic errors, you basically go back to fixing the source code. You go and fix the errors. Now after compiling and there is no errors, it is going to be converted into a object code. Number 3 is going to be converted into object code with no errors. Now after it's converted into object code, the CPU is going to execute the object code to obtain the results. So when executing, that is when you're going to get runtime errors. So whenever you get an error when the program is running, that is called a runtime error. So it basically matches the name. The program is running and that is when you get an error, a runtime error. So if you don't get an error, you basically now have a working program. So this is basically a summarized version of everything that we looked at so far. Now, programming errors. Often, when the computer is compiling or interpreting your source code, an error, whether minor or major, will cause it to either output wrong results or not reach this stage of output at all. There are different types of errors. Excuse me. So the syntax error. This occurs when a mistake is made in the language rule. So remember, the syntax is basically the rule of the programming language. So once you made a mistake in that rule, that is called the syntax error, or it's a mistake in the language rule or sentence structure. Example of syntax error includes misspelling the variable or keyword. Syntax errors are going to stop the program instruction or source code from being converted. So these errors here, syntax error, is actually tested before the conversion or during the conversion. So let's see what's wrong here. Incorrect syntax, since an operator such as or is missing. How is that missing? Where is it missing? Is missing spelling error in begin. If something, then print OK. Not seeing where it is missing. H. Either way, we know that syntax basically means, where is incorrect syntax since an error such as or is missing. Where is or missing? If H. Well, basically this here is missing a operator. Well, it shouldn't have been or, it should have been equal. If age is equal to 42, then print OK. So that's the syntax error here, because it's missing an operator where the rule is for it to have an operator to carry out this action here. Now, a logic operator. Logic errors occur when a programmer makes mistakes. When you make mistake in the sequence of programming sentence, such as the wrong mathematical formula, wrong operator in the expression, incorrect use of looping, the program will usually compile. That is, the compiler will be able to convert it from source to object. So if you notice, if you have a logic error, the program is still going to compile. Why? Because you did not commit a syntax error. A syntax error is when it's going to stop compiling, because you did something wrong with the program. But with a logic error, you didn't do anything wrong. You just use it incorrectly. That's basically what's happening. You used something incorrectly. Everything was done right. It was done following the rules, but you used it basically in the wrong way. That's how you get a logic error. Now, compilation with logic error does not generate syntax error or warning message. So you basically got to go and look to see why are you getting this wrong calculation and so on. But when the program produces the wrong result, that's how you're going to know that something is wrong. So these are much more difficult to troubleshoot, because you have to go through it manually now to try to figure out what is the problem. So an example of a logic error, this segment of code will output a page when x is less than 10. If x is less than 10, then print a page. Well, I guess that's the error there. However, the program intended the statement to be the same thing. Oh, they intended it for it to be greater than. So here we have that's the logic error here. So they accidentally maybe they don't know what's less than or more than, so they used the wrong sign. So it is correct. It did follow the syntax. It used an operator, but they used the wrong type of operator. However, the error of putting the wrong symbol in the code means the output will be printed as x is less than 10, when it begins with greater than 10. Good. So that is the difference between logic and syntax error there. Now, what is debugging? Debugging is the process of finding errors in the source code. So you're trying to look for errors. You're understanding why they occur, which is called diagnosis, and correcting them. Debugging, you're looking for those syntax and logic errors inside of your program, trying to understand why they occur, and then fixing them. Now, errors are found through error messages generated by the program or operating system, because the program does not behave as expected. Now, as it says here, you know what type of error you're going to get. You know what is the error based on the error message. But as we just learned, you do not get an error message with a logic error, because everything was done correctly, just that you designed it wrong. So the only time you're going to get an error message is with a syntax error, because the system will know you basically did not follow the rule correctly. So this is where you're going to get a error message, and the logic you will not get an error message. Now, executing the program. If you have translated your program to object code without errors, you can now execute it to see the results. The final two terms commonly used with program execution are program loading. You're copying a program from hard disk to main memory in order to put the program in a ready-to-use state. So you converted the source code into the object code. So it's now in this object code. Now this code has to be loaded into main memory for it to be in a ready-to-use state. Remember, we talked about this since in the beginning of IT. Instructions must be in memory for it to be executed. So this instruction now is going to be in the memory. Now next, we have linking. Combining various pieces of code and data together to form a single execution object code that can be loaded into memory. Linking can be done at the time of compile time, load time, run time, and so on. So if another file, another program has some other necessary information for this instruction to be carried out, they will be linked together. They will be combined together in the memory to carry out the instruction. So once your program compiles, you may either see the result on the screen or you see another error message. So you run the program is running, you see the result on the screen, or you get another error message of some sort. Now, runtime errors. Runtime errors occur as the program compiles or runs. These errors are usually due to unexpected events, such as maybe division by zero, lack of memory for the computer to manipulate the data. Runtime errors can be very difficult to trace, as the program may produce results most of the time. So whenever you run the program and you get an error, when you're compiling the program, because remember, when you're compiling, that's almost like running also. That is called a runtime error. So example of a runtime error, for average equal 1 to 5 do, results dot dot dot. So this is divided by average minus 1, which is going to basically be 0. So 1 minus 1, 0. So the program will produce an error message or cause the computer to freeze when the value of average becomes 1. The statement will be results equal dot, which is a division by 0. So the next chapter, testing and debugging techniques. Testing and debugging are necessary stages in the development cycle. They are best incorporated early. Testing begins when you start to plan the program and continues until the program is completed and put into daily use. It is used to ensure that the program is complete and does what it is meant to do. So that is why you test and debug, to ensure the program is running as you want it to run. Now, testing attempts to find problems in your code. Debugging isolates and fix those problems. So test, you're trying to find the problem, and debugging, you're basically analyzing, you're trying to find what is the problem and to fix the problem. Now typically when you test and debug your program, you need to ensure that it runs without crashing or generating error message. So when you run the program, it doesn't crash, you don't get any error message, you're good to go. It carries out a reasonable action, produces error message for a range of scenarios, helps the user to continue restart the program if the unexpected user or system occurs. Now errors can occur at any stage of the software application. They may happen frequently if you make errors while using the application. For example, they occur as a result of problems such as power failure, so low voltage, high voltage, loss of power. Obviously that's going to cause errors in the program. Now testing can prove that your program is fully correct. It can certainly find defects, also called bugs. So remember, bugs, it refers to an error in your program, but there's no way to be sure there's absolutely no errors in the logic of the program code. Therefore, the earliest defect is found, the easier it is to fix it. Testing the program involves creating a set of test cases. So when you're testing the program, you as the creator are going to enter various values, various types of data. You don't enter exactly what should be entered. You entered random information. Like you try to be a child and just enter random information and see what is going to happen. So you test the program to ensure that it is going to work how you want it to work. You check to ensure the program is running with each test case, and checking that the performance of the program is what you expect. Test cases. A test case document that values the values that are input and compares the predicted results with the actual results when a program is executed. So a test case document the values that are input and compares the predicted values with the actual value. So you might have remember your trace table, you're going to predict what values you're supposed to be getting. So similarly, with this test case here, you're going to check the values you're getting from the program, which is called the actual value, with that predicted value from your trace table, and to see if they corresponded. And that is how you'll know your program is working correctly. You must consider a range of values when you're testing. It is important to ensure that every conditional branch, loop, and statement of the program is actually tested by using a variety of test cases. Black box testing is used to check that the output of a module is as expected given certain inputs. The term black box is used because the actual code is being executed is not examined. So black box testing, you're checking to see that the output is what you expect it to basically be. You don't care about so much about the code, you just focusing on the output. Now the black box test provides no information about whether all statements or loops of the test module are actually working or not. Black box testing attempts to input values, process the data, and display the values, because as mentioned, it's only focusing on giving you that correct output based on your input. Now a white box test case are designed to examine the inner structure. So if you notice black box, we're ignoring the inner, but here now with the white box, we're focusing on the inner. We're examining the inner structure of the program and are one of the most important test methods. The test method checks the accuracy of the module from input through every possible path, which is going to include all of your branches, all of your loops, all of your conditions, everything is going to make sure test everything to see it is working. If you actually notice, they put a diagram of a flow chart in here. So where it starts, a process, a decision, another process, the end is going to test and make sure all of that is basically working. Now, since testing every value is impractical, you should choose a range of values to check specific error conditions. You should also be aware of which test data, if any, would be expected to produce results. So you should be aware, like for instance, you're creating a calculator. You should be aware that entering a letter is going to cause an error. So it shouldn't be something that you have to be worried about now, that you have to go and fix that type of error. Examples of values that you should test. You should test empty strings, so basically putting in a space and see what happens. String consistently solely of white space. String with leading or trailing white space. Special fonts. So when you're testing, you put in characters with a lot of space, only space before the text. You put in symbols, you put in foreign keys, and you see what happens. You put in no number, you put in a 0, you put in a large positive number, a small positive or negative number, and all these other examples to see how your program is going to work. Now consider the program that gives the user access based on the correct username entered in the log screen. Examples of username and password as test cases include combinations. So that's the username, that's the password. So what are they trying to tell us here? Testing has to be planned. Some sections of the program often have to be tested before the completion, and this often includes testing the other subroutines which they may interact. The results of these tests determine the quality of the application. Although quality varies from system to system, some attributes include reliability. This is the probability that the inputs to and use of the software will not cause it to crash at a specified time under certain conditions. So how reliable is the data? Is the program stable? A software system is stable or robust if any error in its operation does not result in an irreversible damage. So I guess it's also reliable when it can accept any form of input also. Maintainability. This means how easy it is to debug, modify, expand, and so on. Usability. The system should be flexible, should allow flexible input for the user. The result output should also be clear, well structured, easy to interpret. Error message must be provided in a form that the user can understand. So that is what is meant by user friendly. It being user, that is the usability once it is user friendly. And portability. This is the ease with which a software system designed for one type of computer can be adapted to different types of computers. So these are some attributes that a program should have. It should be reliable, it should be stable, it should be able to be maintained, the usability should be user friendly, and it should be portable. You should be able to take it from one system to another. Now our final chapter, documentation. This is an important part of software design process. Several types are produced during the process. Documenting programming code. Documenting your code means typing short phrases, or phrases, that should have been phrases, or comments describing what your code is doing. So like when you write a line of code, you would put some sort of comment. Like for instance this one here. So we have a where I'm assuming between these asterisks here, this is the comment. So it's saying rem, this program will output a single sentence, and I guess this could be the single sentence here, but the main focus is that the comment to the phrase tell you what the program is basically doing. Now comments are placed alongside your programming code are useful if the program needs to be debugged or updated. So if you need to debug it, if somebody else needs to be debug it, that's why the comment will be close to the code. Now if you write your code for your SB and you review it a month later, you may spend some time trying to remember what section was supposed to achieve. So hence, comments therefore help you and others understand the purpose of your code, especially since your teacher or motivator will be reviewing it. Now many students write their comments after the program is finished working. If you leave the comments for later, you may not remember what to use for the method, using different variables, or used another set of code that doesn't resemble the requirements. Then you may resort to typing in the comments as similar to the code. This is not a good method. Comments in programming code should include the following: an overview of the process and tasks rather than rephrasing. So basically state what is the process doing, what the calculation doing, what the next step is doing, the name of the author, the name of the program, even the contact information. Those can be in comments. That's very those are very important to add to a program. Who created the program, what date, and so on. What's the purpose of the program? The date the program was created, and if you finally found the solution to part of a code that did not work, you should document what you did and include any comments to explain the section. So if a certain part was not working, you document how you fixed it. Now adding comments to your programming code may seem like a tedious task. However, if you add them while writing your code, you may find that explaining the section will help you understand the programming. So let's look at the Pascal one. So remember in Pascal, we use the curly brackets here to indicate the comment. So notice the curly brackets there, and it basically says that this program will output a single sentence. I'm not sure why they have everything in curly brackets. For VBA, it seems as though the comments are using a single quotation mark here. Now user documentation. User documentation is concerned with what the program does and how the end user makes the program do what it's supposed to do. It is usually the first contact they will have with the system. It may give details of the input data, format output, such as a printer, save file, and so on, how to access features of the program, how to interpret any system message. So basically, it's going to give you information on how to use the program and how the program works. User documentation should be structured in such a way it's not necessary to read it all before starting the application. It is usually integrated as part of our online help with lots of blogs, online chat rooms to share information on how to troubleshoot and use the system more efficiently. 5 common components of user documentation. A system overview, which is going to explain what the system can and cannot do. Installation documentation is going to explain how to install the program basically. How to recover from errors, how to solve basic problems. It's going to have an introductory manual that explains in simple terms how to start the system. A reference manual that's going to describe the details of all the features and how everything works. And then we have an optional system administrator guide which explains how to react to situations which arise while the system is in use, and it also carries out system housekeeping tasks such as making a system backup. And with that brings us to the end. That should brings us to the end of programming, as we don't need to go into detail of the various programming languages.